Hello everyone, you're welcome to my online YouTube channel, Akeem. We have another topic to destroy this morning, and the topic we are going to consider this morning is simultaneous equation. What is the meaning of simultaneous equation? Simultaneous equation involves a situation whereby you have more than an equation to solve, and you are going to find the values of the variable used in that equation. For instance, let's consider the equation on the board. I have the first one here. You can see there is x, there is y. Consider the second one here. There is x, there is y. That means for us to solve these two equations, we are going to find the values of x and y in the two equations. How do we go about solving that? To solve any simultaneous equation, there are three methods that we can use. The first method is known as elimination method. The second method is known as substitution method. And the third method is known as graphical method. Now, we are going to limit ourselves to the first two, that is elimination method and substitution method, to solve the two questions on the board. The first question, I am going to use elimination method to solve it, while the second question, I am going to use substitution method to solve it. Now, let's look at this first one here. We have the first equation, 2x minus 3y is equal to 10. I can represent this equation as by equation 1. I have the second one, 3x plus 4y is equal to 15. I can represent this one by equation 2. Now, how does that name elimination come into play? To eliminate means to kill one. To kill. How can we kill? For us to use elimination method, we have to ensure that we balances the coefficients of any of the letters that we want to eliminate in both equation 1 and equation 2. Like let's assume now I want to eliminate x. If I'm to eliminate x now, I will ensure that the coefficient of x in equation 1 and the coefficient of x in equation 2 are the same. Like here now, this one is 2 and this one is 3. So how do I ensure that their coefficient balances? For the coefficient of balances, I'm going to multiply both equation 1 by exchanging the coefficient of x in equation 1 and equation 2. Look at this equation 1. Coefficient of x here is 2. Coefficient of x here is 3. I am going to multiply equation 1 by 3 and multiply equation 2 by this 2, the coefficient of equation 1. That means this 3 now, I will use the 3 to multiply everything here. And I will use this 2 to multiply everything here. If you do that, you are going to have 3 times 2x will give us 6x minus 3 times 3y will give us 9y. Is now equal to 3 times 10. That will give us 30. I have the second one, 2 times 3x. That will give us 6x. Plus 2 times 4y. That will give us 8y. Is now equal to 2 times 15. That will also give us 30. Are we together? Now, you can see that the coefficient of x in equation 1 and the coefficient of x in equation 2 are now the same. We can as well call this one equation 3 and call this one equation 4. Now that the coefficients are the same, I can now subtract simply because I'm subtracting because I want x to be eliminated. 6x. That means after subtracting, I'll put this sign there. 6x minus 6x. X is eliminated because it will give me a 0. Then the second one I have, minus 9. Look at it. Minus 9. The minus outside is there. This minus, while your y is plus 8, you have 8 here. Minus 9. Minus times minus will give us minus. Then you have your 8. Minus 9 minus 8 will give us minus 17. So this one now will give us minus 17y is now equal to 30 minus 30. That will give us 0. If you divide both sides by 17 now, your y will be equal to 0. Then we can now substitute this value of y is equal to 0, into any of the equation. Let's assume I'm going to substitute into this equation 1. If you are substituting y is equal to 0 into equation 1, that means anywhere you come across y, you are going to represent it with 0. And look at this equation 1. I have 2x minus 3y. That means I'm going to have 3 into 0 is equal to 10. 3 times 0 will give us 0. So this one is out of it. We are now left with 2x is equal to 10. Of course, if you have an equation like this, you need to find the value of x. And for you to do that, you divide both sides by 2. If you divide both sides by 2, 2 will cancel. 2 here is 1. 2 in 10 is 5. So x now will now be equal to 5. So therefore, x is 5 and y is equal to 0. That is the solution to the first equation. You can confirm if you are actually right or wrong by substituting the values of x and y into the equation. Our x is 5. Let's substitute this value into the first equation. Our x is 5 and our y is 0. And the first equation is 2x minus 3y is equal to 10. That means anywhere we see x, we represent it with 5. And anywhere we come across y, we represent it with 0. That means you are going to have 2 into 5 minus 3 into 0. We must get this answer back. 2 into 5 will give us 10. Minus is 0, and that will give us 10. If you substitute it into the second equation too, it will give you this 15 that is here. Now, let's use the second method, which is substitution method, to solve this simultaneous equation. Of course, we can represent this one by equation 1 and represent this one by equation 2. Now, we have x plus y is equal to 42. 2x plus 5y is equal to 57. How can we use substitution method to solve this? For us to use substitution method, you must be familiar with change of subject or formulae, because what we need to do is that we are going to look at the two equations and we are going to make any of the variables as the subject of formula. For instance, I may decide to make x the subject of formula in equation 1, and I may also decide to make y the subject of formula in equation 1. So if you make any variable as the subject of formula in any of the equation, you now substitute into the other equation. For instance, I can write make x the subject of formula in equation 1. That means I want x to be equal to every other thing in that equation 1. If I should do that, I'm going to have, look at my equation 1. I have x plus 4y is equal to 42. If I want to make x as the subject of formula, y will leave here, move to the other side. So if I should do that, I'm going to have my x now will now be equal to 42. When y moves to the other side, its sign will change from plus to negative. So I'm going to have 42 minus 4y. This will now be my equation 3. You will observe that equation 3 was gotten from equation 1. So when you want to use this equation 3 now, you cannot use it with equation 1 again. You are going to substitute it into equation 2. So I can now write substitute x is equal to 42 minus 4y into equation 2. That means anywhere we come across x in equation 2, we are going to represent it with 42 minus 4y. If you do that, you are going to have 2 into 42 minus 4y plus 5y is now equal to 57. Then we can now open the bracket. If you open the bracket, you have 2 times this will give us 84 minus 8y plus 5y is equal to 57. We have this now. Then we can now collect like terms. If we collect like terms, we still have 84 minus 8y plus 5y will give us minus 3y. Minus 3y is equal to 57. 7. That means I can now collect like terms. I need a positive value for y. So 3y will move to the other side. So I'm going to have 84 minus 57 is now equal to 3y. What is 84 minus 57? That will, of course, give us 27. So 27 is now equal to 3y. I can now divide both sides by 3. So we have divide by 3 and divide by 3. 3 we cancel. So our y now, 3 here is 9. Our y is now equal to 9. Then I can now use my equation 3 to get the value of x. If I should use equation 3 to get the value of x, look at equation 3. I have x is equal to 42 minus 4y. That means I'm going to represent y with 9. So if you do that, you're going to have x now will now be equal to 42 minus 4 into 9. 4 times 9 is 36. So I have 42 minus 36. So my x now will now be equal to 6. So therefore, x is equal to 6 and y is equal to 9. You can substitute their value into the two equations. You will of course get this. X is 6. I have 6 plus 4 times 9, 36. 6 plus 36 will give us 42. You can try it for the second one. We are going to stop here now. In our next episode, we'll take it off from here. Thank you very much.